Hello, this is Professor Perez. We are going to use this piecewise function to evaluate some one-sided and two-sided limits and talk a little bit about their relationship. Notice that x equal -5 and x equal +3 are not in the domain of this function. Now let's begin with x equal -8. Be sure to look at how both the x and y values are changing. Notice as x approaches -8 from the left, y is approaching -2. Let's demonstrate this one more time. Now here we can visually see that the limit as x approaches -8 from the left of f of x is in fact -2. Now let's take a look at the limit as x approaches -8 from the right of f of x. Notice that in this case, as x approaches -8, y is approaching -4. Therefore, the limit as x approaches -8 from the right of f of x is -4. Now let's take a look at the two-sided limit about the x value -8 and notice what the y values are doing. Let's take a look at this one more time. Remember that in order for the two-sided limit of a function f of x to exist, in this case at x equal -8, the one-sided limits must be approaching the same value, regardless of whether x approaches -8 from the left or from the right. At x equal -8, this is not the case, and therefore we say the two-sided limit does not exist. But let's not forget about the function value at x equal -8. It is in fact equal to -4. Now let's take a look at the limit as x approaches -5 from the left of f of x. Notice that the y values, or function values, are increasing without bound. Therefore we say the limit is equal to +∞. Now let's approach -5 from the right-hand side. Notice in this case that the y values, or function values, are decreasing without bound. Therefore we say our limit is equal to -∞. Now let's look at the limit as x approaches -5 of f of x. Remember, this is a two-sided limit. Notice that the values of f of x are approaching +∞ as x approaches -5 from the left, and -∞ as x approaches -5 from the right. Here we can clearly see that our one-sided limits are not approaching the same value. One is increasing without bound, and the other is decreasing without bound. Therefore, we conclude that our two-sided limit does not exist. But what about the function value at x equal -5? Remember, x equal -5 is not in the domain of our function. Therefore, our function value is undefined. Now let's take a look at the limit as x approaches 3 from the left of f of x. Notice that our function values are increasing without bound to +∞. Therefore, our limit is equal to +∞. Now let's approach 3 from the right. Once again, we can see that the function values are increasing without bound towards +∞. Therefore, again, our limit is equal to +∞. Now we take a look at the limit as x approaches 3 of f of x. Remember, this is a two-sided limit. Notice that in this case, the one-sided limits are both increasing without bound to +∞. Therefore, we say that our two-sided limit is equal to +∞. How about the function value at x equal 3? It is undefined. Remember, 3 is not in the domain of our function. Now let's take a look at the end behavior of our function. Let's find the limit as x approaches +∞ of f of x. Notice that as x increases without bound, the function values approach 4. Hence, f has a horizontal asymptote of y equal 4, and therefore the limit as x approaches +∞ of f of x is equal to 4. Let's finish now by finding the limit as x approaches -∞ of f of x. Notice that as x decreases without bound, the function values also decrease without bound. Therefore, the limit as x approaches -∞ of f of x is equal to -∞. Well, that concludes this presentation, but here are a few practice problems for you to work on. Find the limits. The solutions will be given to you at the end of this video presentation. And by the way, thanks for stopping by.